Hi everyone. So now we are going to analyze the complexity of merge sort. So merge sort, as you know, it's a divide and conquer based sorting algorithm, and it has three main steps that we already know. Um, so let us see what it does. Okay. So it's a recursive algorithm, and for many recursive algorithms, we will see the equation method that we have discussed comes very handy. Okay. So we'll form an equation for the time complexity of merge sort, and we will try to solve it. So what it does, so in this method merge sort, we said we have an array, we break it into two parts. Okay, we sort the two parts and then we try to merge them. This is what we actually do. The first is breaking into two parts. Okay, so this is a base case, this take constant time. So every time we check base case, we spend a constant time. Then we have finding out the midpoint, this also takes constant time. Then we have merge sort on this part. Okay, so let's say the time taken to merge sort on the entire array is tn. Then for the smaller part it is going to be t of n by 2. Okay, so we can say this is t of n by 2. This entire array takes t of n. This is also t of n by 2. And then we have a merge function which we know combines the two arrays in linear time. Okay, so it takes linear time to combine the two arrays. So this time would be linear, so that means it can be written as k into n. So we can write t of n as k plus t of n by 2 plus t of n by 2 plus kn. So if I try to simplify this, it becomes k plus 1 into n plus 2tn by 2, and we can still write it as some constant c into n plus 2tn by 2. Okay, so I can put k plus 1 as c, it's a constant. So this is the recurrence that we need to solve to find out the complexity of merge sort. So let us try to solve this recurrence. So we have t of n as k of n plus 2t n by 2, and t of n by 2 can be written as k of n by 2 plus 2t n by 4. T of, but now what I have a 2t here, I have a t here, I want to cancel out these terms, so I will multiply this entire equation with 2. Okay, so let's say this would become something like this, 2, this would become 2, and this would become 2 into 2, that is 4. Okay, 2 into 2, that is 4. Now what I have next is I have t of n by 4 as k of n by 4 plus 2t of n by 8. Okay, now again what I need to do is I have a 4t here, I have a t here, I need to multiply this equation with 4. So it becomes 4kn by 4, and this will now become 8. So similar thing will go on for all of these equations. We will have something like t of 1 left, that is again k of n by 2 raised to the power something something x. Okay, and plus 0. So what we will do is this would effectively become very small. Okay, so all of these terms would get cancelled, and okay, so what we are left with is we are left with terms like these, k of n, k of n, k of n. So effectively you will also multiply it with some 2 raised to the power x, 2 raised to the power x, and this will go off. So what you will observe is from every equation you are left with kn, this 2 goes off, you're left with kn, this 4 goes off, you're left with kn. So from the left we are left with t of n, and from the right we are left with k of n, and summation I goes from 1 till how many equations you are going to have. Okay, so you're going from n to 1 every time doing every time dividing it with the factor of 2. Okay, for example, if n is 16, it becomes 8, then it becomes 4, then it becomes 2, then it becomes 1. So how many iterations did it took? It took log of 16 to the base 2, that is 4. So effectively we have log n such equations. So if you do this, it becomes k of n into log of n to the base 2. And talking about the complexity, it becomes order of n log n. Okay, so this is why we said the complexity of merge sort is n log n. So I hope now you understood why and how the complexity of merge sort algorithm is n log n, and it is much faster than what we have seen for bubble sort. Okay, so this is a n log n complexity. So roughly it's linear because log n factor is very small, so roughly it is growing linearly with the time. Okay, so you can see uh, with every increment in a factor of digit, we have one more digit added in the time, so roughly it's close to linear. Okay, so that's it, that's all for this lecture.